Hello all. Topic of this video session is Principles of Operations Research Modeling and Approximations of OR Models. Principles of Modeling. Here are some of the general principles in formulating OR models. First one, do not build a complicated model when simple model can accomplish the task. Common guiding principle for mathematicians is to build a strong model which has wide applications. But in practice, it is advised to keep it simple. Second is, beware of molding the problem to fit the technique. Models cannot be built for all real world problems. It is not advisable to develop a technique first and try to fit a problem to that technique. It is like saying a cure is found and search a disease to fit it, which is highly impossible. Third, the deduction phase of modeling must be conducted rigorously. A thorough and careful deduction phase helps researchers to find out hidden bugs which produce results which are not consistent with the intention of the model. Fourth, models should be validated prior to implementation. Validation is the process of determining the degree to which a model and its associated data are an accurate representation of the real world. A model is said to be valid if it can provide a reliable prediction of the system's performance. For example, if a model is constructed to forecast the monthly sales of a particular commodity, it could be tested using historical data to compare the forecasts it would have produced to the actual sales. Also, periodic re-evaluation of the model is necessary. A model should never be taken too literally. A model, however sophisticated it cannot represent a real world situation. For example, if a model of Indian economy is built with many researchers spending a great deal of time and money in getting all kinds of complicated interactions and relationships, then it can be easily considered that model can duplicate itself the real problem. But this is a dangerous misconception. A model should neither be pressed to do nor criticized for failing to do that for which it is never intended. A model should not be stretched beyond its capabilities. For example, the use of a forecasting model to predict so far into the future that the data on which the forecasts are based have no relevance. Beware of overselling a model. Here, overselling implies to emphasize the good points excessively or praise too highly. An OR professional must remember that most of the non-technical benefactors of an operations researcher's work will not understand the high-level modeling language. More complicated technical words in describing the model will increase the burden of responsibility on the OR. Some of the primary benefits of modeling are associated with the process of developing the model. A model never contains the full knowledge and understanding of the real system that a builder must acquire to build it, and there is no way to convey this knowledge and understanding properly. Hence, a model is in general not useful to anyone else as it is to those who build it, and its only benefit occurs while it is being built. In such case, the model will have no further value once it is completed. A model cannot be any better than information that goes into it. Models may manipulate data provided to it. It cannot correct the data for any errors. For example, models consolidate data or convert data into more useful forms, but models cannot generate data. Models cannot replace decision makers. Decision making refers to making choices among alternative courses of action. OR models can aid decision makers and thereby permit better decisions to be made. But models do not make the decisions by themselves. Experience, intuition, and judgment are always important in decision making. Other points to be noted by the OR model builders are validity of the model, usability of the model, value of the model, cost and sophistication of the model, time required to formulate the model. Another concept to be discussed here is approximations or simplifications of OR models. While constructing a model, certain objectives are to be considered. Like, the model should be as accurate as possible, it should be as easy as possible in solving the problem, solution of the model must be understandable, management must be capable of using the model. So the reality of the problem under study should be simplified by having less variables by omitting certain unnecessary variables. Changing the nature of variables. Example, considering variables as constant or continuous. Aggregating or grouping the variables of similar nature into similar groups. Changing the relationship between variables, that is, considering them as linear or straight line. Modifying the constraints, example, inequalities into equations by adding slack or surplus variables. Thank you.